I want you to picture the last time you drove past a highway expansion or maybe a brand new housing development. You know the exact look I mean.
Oh, yeah, the ubiquitous gray scar.
Exactly. You've got this massive hill that's been cut right into, and holding it all back is just this fortress wall of concrete blocks.
Right. It's the absolute default setting for civil engineering. We literally call it brutalist for a reason.
Yeah, and I mean, it works, right? It does the job. But it always feels like this heavy-handed declaration of, humanity was here and we poured a ton of cement.
It solves a physics problem. It holds back the Earth. But it creates this massive aesthetic problem in the process. It's hard, it's hot, and water just bounces right off it.
Right. But today, we're looking at a stack of research that claims we can totally freak that script. We're doing a deep dive into the Varden living retaining wall system.
And this is a really fascinating concept.
It is wild.
Yeah.
The promise here is a retaining wall that starts off looking like a structure, but eventually disappears completely into vegetation.
And just to set the stage for you, we're not talking about hanging a few flower pots on a wooden fence.
No, not at all.
This deep dive is based on source material from a partnership between two companies. You have DIY retaining wall, which brings all the hard engineering rigor, and Verdtech, which brings the product innovation.
So it's a mashup of heavy civil engineering and living garden design.
Exactly. We were looking at a system designed to replace those massive concrete bunkers with something that is technically a vertical garden, but functions just like a dam.
And the mission for this deep dive is to answer a question that honestly completely baffled me when I first looked at the spec sheet.
The weight difference.
Yes. How can a plastic crate that weighs 3 pounds, literally the weight of a decent laptop, replace an 80-pound block of solid concrete?
It sounds impossible.
Right. And does that actually work when you are trying to hold back actual tons of soil pressure?
That is the central tension of this whole system. We are moving from gravity-based systems where sheer mass is the only thing that matters to geometry-based systems.
Okay, a shift from brute force to smart engineering. I like that. Let's start with that 3-pound revolution concept, because the logistics of this seem to be the biggest initial selling point.
Oh, without a doubt. The data comparison is just stark. A standard concrete retaining wall block is anywhere from, say, 60 to 80 pounds.
Which, if you have ever tried to landscape your own backyard, you know is perfectly manageable for about the first 3 blocks.
Right, and by block number 20, you are rethinking every life choice that put you in that backyard.
Exactly. And if you're doing a real project, like a 50-foot wall, you are talking about pallets upon pallets of these things. You are moving literal tons of material.
And that introduces a massive logistical hurdle. Heavy machinery.
You need a bobcat.
You almost certainly need a skid steer or a bobcat if you're using concrete. You physically cannot move that much mass efficiently by hand, which is fine if you're building a highway overpass with wide open access.
But most people aren't building overpasses. They're just trying to fix a crumbling slope behind their house.
Right. And that is where the access-constrained project comes into play. This is a huge issue in urban and suburban planning. Imagine you have a townhouse or a backyard with a really narrow fence gate.
A bobcat simply doesn't fit through there.
It doesn't. So if you choose concrete for that project, you are hiring a crew to hand-cart 80-pound blocks, one by one, through a 3-foot gate.
The labor cost would just explode.
Exactly. Versus the Varden block, which is 3 pounds, you can literally carry a stack of 10 of them in your arms.
So it changes the entire workflow. It goes from a heavy civil construction project to essentially a manual assembly job.
You don't need the hydraulics.
Yeah.
You just need some basic manpower. But there is another angle to this weight difference that connects to the broader supply chain, too.
You mean transportation?
Massive transportation savings. Think about the fuel required to truck pallets of solid concrete across the country. It is incredibly energy dense in the worst possible way.
Because it's so heavy. Right. But when you ship these polymer cages, you are essentially shipping air until you fill them on site. The carbon footprint of getting the material to the job site is just a tiny fraction of traditional masonry.
Okay, speaking of the material, though, let's address the elephant in the room here.
Yeah.
It's plastic.
Yes.
The source material specifically says reprocessed polymer. Now, usually when I hear recycled plastic in a construction context, I worry about durability. Is this just, milk jugs melted down?
That is a very valid concern. But there is a huge distinction here between consumer-grade recycled plastic and engineering-grade reprocessed polymer.
Okay, how so?
The material science reports indicate this stuff is specifically formulated for UV stability and freeze-thaw resistance. So it's not just about taking waste out of the landfill, although that circular economy aspect is a really nice bonus.
Right, turning waste into infrastructure.
Exactly. But fundamentally, it's about creating a material that will not degrade when it's baking in 20 years of direct sunlight.
So it's not going to get brittle and shatter after a few hot summers. That is the claim. In fact, unlike concrete, which is actually porous and can absorb water.
And then crack when that water freezes.
Right, exactly. Polymer is impervious to that specific type of degradation. But, and this leads us to the big structural question, the material itself isn't actually what is holding back the hill.
Okay, this is the part I really need to unpack. Because my intuition says a heavy hill needs a heavy wall. If I lean a plastic crate against a sliding mudslide, that crate is just going to crumple. How does this system stand up?
You are touching on the core difference between a gravity wall and a mechanically stabilized earth wall, or MSE for short.
MSE, got it.
A concrete wall is a gravity wall. It works simply because it is heavy. It pushes back against the earth because it is just really hard to move.
It's just a sumo wrestler holding the line.
Basically, yeah. But the Varden system is an MSE system. The plastic block isn't the muscle. It is just the skin. The real strength comes from two distinct things, the batter and the geogrid.
Let's start with the batter. The diagrams and the sources show the wall leaning back into the hill.
Correct. It is not a vertical, perfect 90-degree stack. It has a built-in setback.
And what does that do?
By leaning the wall back into the slope, you are actively shifting the center of gravity. You reduce what engineers call the overturning moment. That's the force that's constantly trying to tip the wall over face first.
Okay, so the geometry itself is fighting the tipping. That makes sense. But what stops the soil from just blowing straight through the plastic mesh?
That is where the geogrid comes in.
The sources describe it as a mechanical connection. But to the untrained eye, honestly, it just looks like a plastic net that you roll out into the dirt.
Calling it a net severely undersells the physics happening there.
Yeah.
Geogrid is a high-tensile material. Here's how it actually works. You lay this grid between the layers of the blocks, and it extends back, say, 4 or 5 feet into the soil behind the wall.
Okay.
Then you pack the soil directly on top of that grid.
So the dirt is just sitting on top of the grid?
Exactly. And this creates massive friction. The individual soil particles literally lock into the apertures, the little holes of the grid.
Oh, I see.
This effectively ties the face of the wall into the entire soil mass behind it. The weight of the soil itself is pinning the grid down.
Wow. So for the wall to fall over, it would have to drag that entire 5-foot deep chunk of earth with it.
Precisely. It is a fascinating shift in perspective. You are not building a wall to fight the dirt. You are using the dirt's own weight to anchor the wall.
The soil literally becomes the structure.
Yes. The plastic blocks in the front, they're essentially just there to stop the dirt at the very edge from eroding away and to give you a nice place to put plants. They are the facade, not the backbone.
Okay, so if the soil provides the strength, we definitely need to talk about the different zones inside this wall. Because looking at the cross-section diagrams, it is clearly not just, fill it with dirt and walk away.
Not at all.
It looks like a complex layer cake of different materials.
And this is exactly where amateur walls often fail. You cannot treat all dirt the same. The Varden system dictates a very strict separation of materials.
In the very front, you have what they call the planting pocket.
Right. That is a small volume of organic, rich soil that is purely for the plants to root in. It holds moisture, it has nutrients.
Makes sense.
But you absolutely do not want that organic soil anywhere near the structural zone behind it.
Why not? I mean, why not just backfill the entire thing with good garden soil?
Because organic soil holds water like a sponge, and water is the ultimate enemy of stability. Behind the block, the spec requires clean, crushed stone.
And there is a separation fabric between the planting soil and that stone.
Yes, and that fabric is absolutely critical. It acts as a filter, it allows the water to pass through, but it stops the fine soil particles from migrating into the stone legs.
Because if the soil got into the stone,
it would clog all the gaps, and suddenly you lose all your drainage.
Which brings us to the absolute biggest killer of retaining walls. We've talked about weight, we've talked about friction, now we have to talk about water.
It's the silent killer of infrastructure.
The expert notes in the source material are very grim about this. It says, quote, "Trapped water is the biggest threat to any retaining wall."
And it is not an exaggeration. We call it hydrostatic pressure. Water is heavy. It's about 62 pounds per cubic foot.
That adds up fast.
Oh, incredibly fast. If water builds up behind a wall, and cannot escape, the pressure grows exponentially.
Yeah.
It honestly doesn't matter how strong your geogrid is. If you have a swimming pool's worth of pressure pushing against the back of your wall, it will blow out.
So how does the Varden system actually manage that? Because since it's a living wall, you are intentionally watering it, right?
That is the irony of the whole system. You need water for the plants to survive, but you need to banish water from the structure to keep it standing.
Right.
Remember that column of clean crushed stone behind the blocks we just talked about?
Yeah.
That acts as a vertical drain. The water hits it, and because there are gaps between the stones, it falls straight down to the bottom.
At the bottom.
There is a perforated pipe that safely carries it away from the base of the wall.
So the stone is literally just a highway for water to escape.
Exactly. It completely prevents pore pressure from building up.
Yeah.
If you use clay or just regular dirt backfill instead, the water would get stuck, the soil would swell, and you would have a catastrophic failure.
I want to touch on one other failure mode they mentioned, which is frost heave.
Ah, yes.
In cold climates, the ground freezes and expands. I have personally seen concrete walls that have cracked right down the middle because of this.
That's because rigid systems like poured concrete or mortar walls fail catastrophically when the ground moves. They physically cannot flex, so they crack.
Right.
The Varden system, however, utilizes the inherent flexibility of the polymer and its dry stack design.
So if the ground heaves up an inch during a bad freeze?
The wall just moves with it. It is a flexible system. The individual blocks can actually shift slightly relative to each other without breaking the overall connection.
And then when it thaws?
When the ground thaws and eventually settles back down, the wall settles right down with it. It is forgiving in a way that concrete simply is not.
It kind of rides the wave rather than trying to stop the tide.
That is a perfect analogy.
Yeah.
In geotechnical engineering, a little bit of controlled deformation is often way better than brittle rigidity.
Okay, let's move on to the actual build process. We have established the physics. But if I am a homeowner or a contractor looking at this, what does the timeline actually look like?
It's a distinct phased approach.
The sources break it down, and phase one seems to be the one where most people would probably try to cut corners.
Phase one is preparation. And you are totally right. This is where the biggest mistakes happen. You cannot build a retaining wall on top of soft grass or topsoil.
They call it the clean start in the materials.
You have to dig down. You need to reach the compacted subgrade, which is basically firm, undisturbed earth. And then you have to install a 6-inch base of compacted stone material.
This is the foundation of the whole thing.
It's the footing. If this isn't perfectly level and rock hard, the entire wall will settle unevenly. And then, on top of that compacted stone, you use a thin layer of leveling sand.
Why the sand? The stone isn't enough.
Because crushed stone is jagged and rough. It is incredibly hard to get a lightweight plastic block perfectly level on jagged rocks. The sand allows you to tap the block down gently and get it dead level.
Which is crucial, right?
Absolutely. If your very first row is even slightly crooked, by the time you reach your 10th row, it will be a complete disaster.
That makes sense. Then phase three is the stack. And this is where the modular design seems to really shine. The blocks have these side rails on them.
Think of them as auto spacers. You don't need to get out a tape measure to manually check the gap between every single block. You literally just push the rails together and the exact spacing is set automatically.
So it guarantees a uniform grid for the face.
It does, which again, significantly lowers the barrier to entry. You don't need to be a master mason to get a perfectly straight line.
You just snap them together.
Correct. And as you stack each layer, you are simultaneously backfilling with that crushed stone and inserting the geogrid at the specific intervals dictated by the engineering design.
Okay, finally we get to the part that actually sells the product. Phase four, the plants.
The fun part.
The sources show this visual timeline that I think is really important to describe for you listening, because on day one, this thing does not look like a garden.
No, not at all. On day one, it looks exactly like a piece of industrial infrastructure. It is a rigid grid of black plastic pockets filled with dirt. It is very engineered looking, not particularly beautiful.
But then you have the growth phase.
Right. The plants start to root. They spread out. Depending on what you chose to plant, whether that's ferns, succulents, trailing vines, they begin to obscure that plastic face.
And finally, you reach the mature living wall stage.
At this point, the physical structure effectively disappears entirely. You just see a lush, vertical bank of green.
And this brings up a really interesting functional benefit that goes way beyond just aesthetics, the heat island effect.
Oh, this is a massive benefit. Concrete walls have extremely high thermal mass. They sit there and absorb solar radiation all day long, and then they radiate all that trapped heat back into the air at night.
They literally make our cities hotter.
They do. But a living wall does the exact opposite. Through evapotranspiration, which is just plants releasing water vapor into the air, it actively cools the environment around it.
So it's acting almost like a natural air conditioner instead of a radiator.
Exactly. It softens the environment thermally, not just visually.
Now, I want to pivot a bit to the business side of this, because usually when we talk about DIY and civil engineering in the exact same sentence, it sounds like a perfect recipe for a lawsuit.
It usually is.
But the partnership between these two companies operates on a service model they call We Engineer, You Build.
And this is a crucial differentiator in the market. If you go to a big box hardware store and just buy some retaining wall blocks off the shelf, nobody's checking your math. You are entirely on your own.
And if that wall collapses onto your neighbor's car...
That is completely on you. You carry all the liability.
But with the Varden system, it sounds like you don't just buy the blocks and guess.
No. The workflow is entirely different. It starts with a site plan upload. You send their team photos, precise measurements, notes about your specific soil conditions.
Okay.
Then they perform a rigorous engineering review.
So this is basically the safety gate before you even start.
Exactly. Their team of structural engineers looks at your specific situation. They might come back and say, hey, this slope is way too steep for a simple gravity wall. You are going to need 6-foot lengths of geogrid. Or they might say, your soil is incredibly sandy, so we need to adjust the depth of your base.
So they are effectively acting as the structural engineer of record for your backyard project.
In a sense, yes. They are providing a stamped, code-compliant design based on your inputs. And this is huge for liability and for getting local permits.
Because municipalities are strict about this stuff.
Very. Many require an official engineer's stamp for any wall over a certain height, which is usually around 4 feet. This business model provides that level of assurance without you having to go out and hire a private engineering firm for thousands of extra dollars.
It effectively democratizes the safety aspect of heavy landscaping. It bridges that scary gap between an expensive professional job and a really risky amateur job.
It perfectly creates a middle ground. You get professional safety standards combined with amateur labor.
So zooming out a bit here, we have gone from the absolute nightmare of hauling 80-pound concrete blocks to a system that uses a recycled 3-pound polymer cage. It relies on friction and geometry rather than just brute mass, and it literally turns a dead hardscape into a living greenscape.
It really is a complete rethinking of what basic infrastructure needs to look like.
I think that is the key takeaway for you listening today. We have this deep-seated assumption that heavy duty must inherently mean heavyweight.
And historically, to be fair, that was totally true. If you wanted to stop a landslide 100 years ago, you literally built a mountain of heavy stone.
Right.
But with modern geosynthetics and smart geometric design, we can achieve that exact same structural stability with just a tiny fraction of the material mass. We are substituting intelligence for bulk.
And the implications for broader urban planning are pretty exciting.
Oh, absolutely.
I mean, if we can replace the concrete retaining wall, which is arguably the single most boring structure in existence, with a living ecosystem, what else can we change?
That is the provocative thought I'd love to leave people with. Look at the sound barriers running along our highways. Look at the huge concrete dividers in commercial parking lots.
The blank facades of massive parking garages.
Yes. These are all currently hard, hot, dead surfaces that just soak up heat and repel water.
But the technology clearly exists right now to turn them completely green. It is just a matter of adoption at this point.
It is about deciding that we actually want our built environment to function more like a living forest rather than just an open quarry. The Varden system is just one really great example of how that transition can happen, one 3-pound block at a time.
It definitely makes me look at that cracking concrete wall sitting in my own driveway a little differently today. I think it might be time for a renovation.
Just remember to check your drainage first before you do anything.
Always. Good advice. Well, thanks for taking this deep dive with us today. It has been a truly fascinating look at how rigorous engineering and organic gardening are finally shaking hands.
It was a pleasure to explore it with you.
We will see you all on the next deep dive. Stay curious.